In this video, we'll learn about circular doubly linked list. This is a doubly linked list and also it is circular. That is, this first node or head node is pointing on the last node or last node is pointing on the first node. So these are a collection of doubly linked nodes which are circularly connected. So already we saw circular singly linked list. This is doubly linked list. So the benefit of this linked list is you can access in either direction, bidirection, as well as circularly we can access. So far we have seen various types of linked lists. Comparisons, we will do it in some other video. So let us learn few things about circular doubly linked lists. So this is basically a doubly linked list only. So I don't have to explain much. I'll just give you few important points and rest is a student exercise. So let us look at some operations. Like first of all, I want to traverse this. So for traversing, I may be starting from head node. Then I can go to next and next and next node and next node. And again, if I say next, I'll be upon head. So how we have handled singly circular linked list? Same way we should handle it. We have to scan it, all the nodes. And once we reach to head once again, then we should stop. If I want to display linked list, how the code should look like, let us see. I should take a pointer upon head node. Then for printing, print the data, move pointer to next node. So printing and moving, I have to do it repeatedly using do while. Do while P is not equal to head. So if you remember, in a circular singly linked list also we have used do while loop because using while loop it was not possible. So the same thing we have to do here also. Now rest of the operations are similar. Now let me tell you the few important things related to insert operation. So let us look at insert operation. If I want to insert any node at a given position, let us say this is first node, second node, third node, fourth node. I want to insert a new node after fourth node. Then the procedure is same as how we have inserted in a doubly linked list. That is, bring a pointer upon this node, create a new node, fill the data, make this point on this one and this previous point on this one. So this next should point here and this previous should point here. So 4 links I have to modify when I am inserting any node at any place. So the procedure is same as doubly linked list procedure. Then how about inserting a new node before head node? So for this, I should take a pointer and create a new node and fill the data here. Then what are the modifications I have to do? In a doubly linked list, I was supposed in a doubly linked list, we were making only 3 changes. These 3 links were changed. But here I have to modify this last node link also. Instead of pointing on head here, it should point on this one. So this is the change I have to do. So it means I should modify 4 links. So yes, the important thing here is wherever you insert in a circular doubly linked list, you have to modify 4 links. So let us see how I can do that and how much time it takes. This should point on head. And this should point on heads previous, means that node 8. So I will draw a link from here. So how I can get the address of that node? Do I have to traverse the whole linked list? No. I can say heads previous, that is heads previous. So I can get the address of that node in constant time. But I don't have to scan through this linked list and reach there. That's the important point here. If you want to reach that node is actually, we are calling it as last node. So we can also call it as a node previous to head node. A node previous to head node. Because if you take a previous pointer, you will get the address of that node. So that you can get it in constant time. So for adding a new node before head node, the time will be constant because you don't have to scan through the linked list for reaching that last node. I will complete other links also. So this is pointing on this one and the previous is pointing on that node, and heads next, this should be pointing on this node, and this 8. How I can reach on that node? T is previous. Already I have a link there. So that should be pointing on T. So now you can see that from T I'll be going to this node 6, then 6 to 9, 9 to 2, 2 to 7, 7 to 8, 8 to again T. So yes, this is connected circularly. So how much time it has taken? Just create a node and modify the links. So the time is constant. So if you are inserting a new node before head node, time is constant. And one important property we learn is that to go on that node, we don't have to scan through the linked list. Just take a previous pointer and you can go there. That's all. Similarly, you can try out delete operation by yourself. I have shown insertion operation. That is sufficient. Delete, you work out on it. It's very easy. Then few more important things I'll tell you. If suppose there is a single node head, there is a single node. Suppose the value is 6. Then how it should look like? This next should also point on itself. Previous should also point on itself. So then it is circular doubly linked list. And if there is no node at all, then linked list is empty, then it should be null. If you remember from circular singly linked list, there the problem was if it is null also, we wanted it to be circular. So if that is the case, then you should have one more dummy node, that is head node, empty node. So anyway, I don't want to include that one here. So this topic remains as an exercise for you. So you prepare the complete code for all the operations on this one. So basically main important operations are insert and delete, complete insert operation and delete operation. These operations you must write down complete code. So what are the cases? Inserting before head or inserting after any other position, all those cases you should take care. So that's all about circular doubly linked lists. So in one of the coming videos, I'll compare all the linked lists and I will discuss the advantages and disadvantages of those linked lists.